One of the things that we would like to be able to do with piecewise functions is to graph them. The simplest sorts of piecewise functions to work with are what are called piecewise linear functions, where each individual piece is linear. Notice that in this example, we see that each of these individual expressions is a linear expression. If that were the entire function, we would have a linear function on our hands. In order to graph this, though, I'm going to start not with those expressions, but with the pieces of the domain. And I'm going to imagine taking my graph and cutting it up into strips, where I have a strip for each piece of the domain. So the first piece of my domain, x goes from -2 to -1. So here x is -2 and x is -1. I'm going to draw these dashed lines at those points. And keep in mind, these are not actually part of our graph. This is just something that I'm drawing to help myself keep track of what I'm doing. So we're not looking at anything like an asymptote or anything like that. These are just guides. After you practice this a few times, you might find that you can do these without drawing these dashed lines. But in the meantime, just go ahead and draw them. They help you keep track. So this is piece 1. And x was between -2 and -1. Let's see. Looking back at my function, x is allowed to equal -2. And on that piece, the expression for my function is 2x minus 1. Okay, so that's my first piece. My second piece is going to be where x goes from -1 to 2. I've already made a cut in my graph at -1. Now I'll make another one at 2. Now I'm going to leave 2 lines empty here after piece 1 and before I go on to piece 2. But in piece 2, x is running from -1 up to 2. And I see that x is allowed to equal either one of those. And then I see that on that part of my graph, the formula for my function is 3 minus x. So on that part of the graph, f of x is 3 minus x. Then the third part of my graph is going to run from 2 up to 4. So I'm going to make one more cut at x equals 4. And this is piece number 3 of my graph, where x is between 2 and 4. X is not allowed to equal 2, but it is allowed to equal 4. And on that part of the graph, the actual expression for my function is 1/2 x plus 1. Okay, so that's my first step. I divide up the graph, and I make a note of which piece of the function goes with which piece of the graph. Now, the next thing I'm going to need to do in order to actually draw my graph is, well, each piece is a line. So we need 2 points to sketch it. anytime we want to draw a line, we need 2 points. And if we have a graph like this, where every strip has 2 endpoints, we're just going to choose the 2 edges of the strip. So for my first piece, I'm going to say, using this expression, f of negative 2 is 2 times negative 2 minus 1, and that's negative 5. One of the points on this line is negative 2, negative 5. And then the other end of this interval, we don't actually use this formula for the function at the other end of this interval. We'll deal with that fact in a minute. But to find this point, we're going to use that formula and say f of negative 1 equals 2 times negative 1 minus 1 equals negative 3. We'll have a second point at negative 1, negative 3. Now those are going to be the endpoints of this piece of my graph. The last thing we want to think about before we actually draw anything is whether that actual point will be part of the graph or not. In this piece, x is allowed to equal negative 2, so this point is in. But x is not allowed to equal negative 1, so this point is out. The points that are actually part of the graph, we draw a filled circle there. So I'm going to draw a filled-in circle at negative 2, negative 5, which is down here. The points that are not included in the graph, just like we did with inequalities, we'll draw an empty circle there. So I'm going to draw an empty circle at negative 1, negative 3. That's right here. And then I'm going to connect those points with a straight line, and that will be that piece of my graph. So I draw a straight line connecting these 2 points. The filled-in circle says this point is really here on the graph. The empty point says points really close to negative 1, negative 3 are on the graph. Negative 1.001, comma, whatever we get if we plug in negative 1.001 in that formula, that's going to be on the graph. I think it'll be like it'll be negative 3.008, something like that, 002, something. Points really close to that empty circle are on the graph, but negative 1, negative 3 itself is not on the graph. Okay, and now we just repeat this process for all of the remaining pieces of the graph. The endpoints of this piece are at x equals negative 1 and x equals 2. So using this formula, I'm going to take f of negative 1 and I get 4. So the point negative 1, 4 will be one end of this piece. And then I'm going to take f of 2, which is 1. So 2, 1 will be the other end of this piece. And I notice that equals is allowed at both of those points. So both of these points are in. At negative 1, 4, I'm going to draw a filled-in circle. At 2, 1, I'm going to draw a filled-in circle. And then I'm going to connect those with a straight line. And that's that piece done. Our last piece has its endpoints 2 and 4. So So using this formula, I'm going to take f of 2 is 2, and f of 4 is 3, which means this one gives me the point 2, 2, and this one gives me the point 4, 3. X is not allowed to equal 2 in this piece, so this point is out, but X is allowed to equal 4 in this piece, so this point is in. 2, 2, I'll draw an open circle. 4, 3, I'll draw a filled in circle. I'll connect those with a straight line, and we're done. Now, does this graph look like anything very much? No, because it's kind of a randomly written down piecewise linear function. But our goal in actually sketching these graphs of piecewise linear functions is to become comfortable with this piecewise function notation, not necessarily to get any graphs that really look like anything.